Titanium has indeed become a highly sought-after metal in the aerospace industry due to its unique combination of properties. Here's a comprehensive overview of why and how titanium became the most wanted metal in this sector. Why titanium? Titanium has a high strength-to-weight ratio, which means it is strong and lightweight. This property is essential in aerospace applications, where reducing weight can significantly improve fuel efficiency and overall performance. It is also highly resistant to corrosion, particularly in saltwater and acidic environments. This property makes it an ideal choice for aerospace applications, where exposure to harsh environments is common. This silvery metal can withstand extremely high temperatures, making it suitable for high-performance applications, such as engine components and heat shields. Titanium has a low coefficient of thermal expansion, which means it expands and contracts minimally with temperature changes. This property is critical in aerospace applications, where dimensional stability is essential. It is biocompatible, meaning it can be used in applications where it comes into contact with the human body, such as in medical implants and prosthetics. How did titanium become the most wanted metal in aerospace? The aerospace industry was one of the first to adopt titanium in the 1950s, primarily for military aircraft applications. The metal's high strength-to-weight ratio and corrosion resistance made it an ideal choice for aircraft components, such as fasteners and structural frames. Improvements in manufacturing processes, such as machining and forging, have made it possible to produce complex titanium components with high precision and accuracy. The aerospace industry's increasing demand for high-performance materials, driven by the need for more efficient and sustainable aircraft, has fueled the adoption of titanium. Advances in production processes and economies of scale have reduced the cost of titanium, making it more competitive with other materials, such as aluminum and steel. The development of industry standards and specifications, such as those set by the Society of Automotive Engineers and the American Society for Testing and Materials, has facilitated the widespread adoption of titanium in aerospace applications. Ongoing research and development efforts have led to the creation of new titanium alloys with enhanced properties, such as higher strength, toughness, and corrosion resistance. The growth of the titanium supply chain, including mining, smelting, and manufacturing, has enabled the industry to meet the increasing demand for titanium. Titanium is used in aircraft frames, skins, and fasteners due to its high strength-to-weight ratio and corrosion resistance. It is used in engine components, such as blades, vanes, and discs, due to its high temperature resistance and strength. Titanium fasteners are used in aircraft assembly due to their high strength, corrosion resistance, and low weight. It is used in spacecraft and satellite components due to its high strength-to-weight ratio, corrosion resistance, and ability to withstand extreme temperatures. In summary, titanium's unique combination of properties, advances in manufacturing, and increasing demand for high-performance materials have made it the most wanted metal in the aerospace industry. Ongoing research and development, industry standards, and collaboration have further fueled the adoption of titanium in various aerospace applications.